Okay, so we will be looking at the n queen problem today. It's a hard problem in recursion. So the question is we have to place n number of queens on the board on a chessboard, n cross n chessboard, in, in a way that none of the queens attack each other. So we can accomplish it by following the given rules where every row should have one queen, every column should have one queen, and no two queens can attack each other. There no two queens can attack each other, and queens can attack in the given directions like this. So the first solution we'll be looking at is the brute force solution, and the intuition is to use the concept of backtracking, where we will place queens at different positions of the chessboard and find the right arrangement. So this is how the recursion happens. We start from the first column and we move column wise. After placing a queen, we move column wise, so we only have to check for queens in its row, in its upper left diagonal and its lower left diagonal, since we are moving from left to right columns, right? So we start by placing queens in the first column, and let's say we place the queen at the 0 0 grid space, and we move to the next column, so we cannot place it here, we cannot place it here, but we can place it here. So after doing that, when we move on to place a queen on the third column, you can see we cannot place it anywhere, or else it'll attack one of these two queens. So we can reject this and we can place the second queen down below, and then start proceed the same way, where we encounter that the fourth queen cannot be placed in any of these columns, or else he'll attack one of these three. So we keep doing this, and when we find a solution, like this is the first solution we will find when we move in this pattern. When we find it, we'll push this grid into our answer, and we'll continue, and we'll push answers all such answers in our final answer, all such grids in the final answer. So we'll look at the code for this. So this is the main function, vector vector n queens. So we first declare a vector of int of answer. So this is going to be our final answer. This is going to final answer. We create a temp of all zeros. Now what this does is it creates a temp array of n size, and n is a n is the length of the board. So this is a 4 cross 4 board, so this temp would be of 4 size. Yeah, sorry, I made a mistake in the code. This temp array should be of n cross n size. So temp represents chessboard, and the given solution should be in the form of an array. That's why we're taking a temp of n cross n. So in case of n equals to 4, it will be 16, and all these answers will be pushed in, and all these answers to the n queens would be stored in temp, pushed into answer, and returned from this function. And then we call the solve function after creating this temp. 0 is the column, int call, answer is temp is the same, and n is n. So now, okay, the base condition for this is when we run out of columns, we push back our temp, and there will be temp in the case we do get a solution, or else there won't be a temp. We'll see. So we'll run a for loop for each row in the column. 1 2 3 4, these are the rows. We run a for loop, we check whether the square is safe to place a queen. The safe function is present here, so we check if it's safe, and if it's safe to do keep a queen there, we mark it as 1. We move the column by 1, we move the column, we add 1 to the column, and we again call the function to place a queen in this column, then this, in this, and then this. If And when we return from the function, we mark back the square 0. And the reason for this is, when if we do return from the function, uh, we have to remove the queens so as to try other combinations. So let's say if you're checking this queen, right? And after checking this queen, we are moving forward to place a queen here. So we'll have to mark this queen back to 0. We cannot keep this as q and proceed to keep a q, mark this as 1. So we'll remove this, mark this as 0, move on. Now we'll look at the isSave function, which checks if it's valid to put q in a square. So this function is the easiest or pretty simple to understand part of this code. So we keep a duplicate row and a duplicate column variables to store row column. So we can uh, we can reset our row and column variables after each check. So first we'll check for the upper diagonal. So it will go from down to up. So for to check for upper diagonal, okay, I have used model uh, basic arithmetic here. So like for example, this square would be our column number, which is 0 1 2 3 4. So the column number is 1 into n for us is 4, plus the row number 0 1 2 3 4, row is 1. So this square would have a number of 1 into 4 plus 1 5. So you can see if we start marking from like 0 1 2 3 4 5. So this is fifth square. So that's how I came up with this expression for our temp. So we'll check if a temp is already marked. If it's marked, we return false, and we do row minus minus column minus minus, which will make our check follow this direction, which is upper diagonal. Once we check for all our diagonals, if we pass all the checks, we reset row column. We do it for our column. We do it for a row, so we decrease column, so which will move our check from right to left in a row. And when it moves, if it passes all the tests, we again reset our row and column and do the same for our lower diagonal from top right to bottom left. We do this by increasing our row value and decreasing our column value. And if it passes this, then we finally return true. And if it's safe to put a q, this function will then put a q, which is mark the square as 1 and proceed. And the base condition, as we already saw, if column reaches outside the grid, we push back our answer. And important thing is to have our answer in a temp array passed by reference, so their values are actually changed and can be modified. So this is our entire n queens function. There are 3 functions, and when I run this, you can see it gets compiled, and if I submit it, it gets accepted. So that's it, guys. Thank you.